Hey guys, welcome to Deep Dive Coding. Today we solve a lead code problem of the day, and that is minimum cost to convert the string 1. So the problem basically says that we are given two strings. That first one is source string and also the destination string. Let me change the color. Okay. And in the source string there are given as for the first example ABCD, and target is also given as ACBE, and also we have provided the three vectors. This is the first one is original and this is change. So basically for original at the 0th positions given A, and for the changed at the 0th positions given B. So if we convert from A to B, so that will take the cost of 2, because cost in the cost 0th positions is 2. So basically we have to convert from source to target string. So if you look into this thing, like this A is same with this, so we do not need to convert, but this B to C we have to convert them. So we check with from B we convert C, it will take the cost of 5. Also we have to convert this index also, that will be C to B. For C to B, this is the C at the original array and B over here, so at the two position second index, and it will also create the cost of 5. And another one is D to E, this will be like over here D to E, it will create the cost of 20. But if you calculate the cost, so first for the first one it will take the 0, and B to C it will take cost of 5, and also C to B it will also cost 5. This one like C to B, this will cost of 5, and another one is D to E, this will cost of 20. So first of all you say that it will create the cost of 30, but we need to we need to calculate the minimum cost. So we can do this way, like for this one C to B, so we can go to C to E positions, this will cost of 1, and E to B positions, this will cost of 2. So C to B will cost of 3. So this is the minimum. We can change this one. So if we change this one, so it will be like 0, 5, 3 and 20. It will give you the cost of 28, and this is with the minimum as given in the output also. And this is the basically problem says. And now look into the constraint part. So constraint is given as source length also given, and equal to the target length. It will be obvious because we need to convert source to target. After that there are also given as, this one is very important things, like source and targets consist of lowercase English letters, and also this one is also lowercase English letters. So basically we are dealing with lowercase English letter. And another important thing is like cost length, original length and changed length, all threes are equal, and they can go at max as 2000. So if you calculate 2000 into 2000, that basically try to compute whether we are able to do the n square operations or not. So yeah, we can do the n square operations. How I am checking, basically for 1 second computer computes 10 to the power 8 operations. So as we are in the positions of 4 into 10 to the power 6, so it will done less than 1 second. So this is acceptable. Now there is also given as 10 to the power 6 as a maximum limit, and so we have to use long, and also this is given like original I and changed I both have to be different. That means there is no cases where changed original, let's say this is in the original array, let's take original array given this, and changed array also given this. It is not the possible, because it is simply saying that if A is a node, then it could not have the self loop exist. So I think you able to consider that. I think you able to find that this is basically a graph problem. So what we can do, we try to create the graph of the directed graph with edge weight. So this will be constructed by, let's say we are from A, we go to B with the cost of 2. This is basically means that way. So if we convert B to C, and it will cost of 5, this will be the edge weight. So let's try to build that graph for the first example. So I already built it over here. So A to B, this will cost of 2, B to C 5, and so on. So if you convert, if you now let's try to dry run. So this is the source, also this is the target. So from A to A, we do not need to change anything, so it will be cost of 0. From B to C, look into the graph. So there is B to C, there is only one path, this is the path, and this will cost of 5. Now C to B have the two paths, one C to B direct path, and another one is through the E. So you can C to E and E to B, these are the two paths. For the C to B, direct path have cost of 5, and for C to E it will cost of 1, and one E to B it will cost of 2. So basically we are given a minimum cost, we can find that will be the 3, and D to E it will be the 20, edge weight is 20, and D to E will give the cost of 20. So because there is only one path exist, so it will give you the 28. So this is just like, I think you observe these things correct. So there are few things to note. First of all, we are using the directed graph. That means if we directed graph means A to B, that means if we are A, we can go to B, but it does not mean that if the B is A, that means let's say in the original array is given as A, and changed array given as B, it does not mean that we can go to B to A. So that's why I am not using undirected graph. So first of all, it will be the directed graph with the edge weight, and cycle also exists, as you already seen over here. There is a cycle, like from the B to C, C to E, and E to B. This is a cycle. So cycle may exist, and also given in the constraint, the cost is always positive. This is a huge significant hints. Actually cost is given 1 to 10 to the power 6. So all edge weights are positive. Now we have the few choices, like we have to, now we are able to find that we have to apply shortest path algorithm in graph. So if you look into this shortest path algorithm in graph, there are few choices for perfect for this problem. So one, we can use the Dijkstra algorithm. This is a single path shortest algorithm, like single source shortest path algorithm. So what we do over here, we start from one node. Let's take a graph. Let's say this is a example graph. Okay, so we want to find the source for this is the source, and from this source we Dijkstra algorithm take one source, this will be the source, and try to compute the all other nodes shortest path. That is used for that is best work for Dijkstra. But as we want that there are so many sources, that means if we want to compute for each transitions, let's say U to V, and there are given, this is in the source string, and this is given to the target string. So if we want to find the U to V the cost, so we each time we have to run the Dijkstra algorithm. So this will be takes too much time, so we want to avoid these things. And another choice is Floyd Warshall algorithms, but there are Floyd-Warshall algorithm complexity is too high. I will discuss complexity in upcoming. Let's try to discuss the Floyd-Warshall algorithm in detail. So let's take an examples of this graph. Now basically we want to in the first iterations. Let's take in first iterations, and there is already given a dist array that will take ij. This means we travel I to j. This will save the cost of that thing. That means at the kth iterations we are do it by few iterations. At the kth iterations we store the minimum distance between I to j using the nodes which is value less than k. So basically means that in the first iterations, let's dist array of from, let's take an example of 1 to, so it will be initialized by 2, because 1 to 2 there is already edge weight, like path exists, but in the first iterations we do not know the from 1 to 6, let's say 1 to 6, we do not know how much what is the shortest path and also the distance. So we will initialize by infinity as the iterations going on. So first of all let's take an through the 1, and we are compute through the 2. When we compute distance 1 to 3 through the 2, so it will give the correct answer. So basically we try to in each steps there are I to j, we want to compute the distance via k. So this will be done using these steps. It will be each time it will be computing that way, like it will simply means like dist of I comma j, store distance between I and j via k node. So we update that dist of ij, that will be the minimum of dist of ij, and dist of ik, that means this edge weight if it is already exist, and dist of kj, that means this edge weight. So in this way we can compute dist of ij, but we run this algorithm n times. Why? Because as the, let's say we run it in kth times, so it will use value of, okay, it will use all nodes whose value less than k. So if we run in the n times, so each and every node is utilized. So at the end of the nth times we will get the minimum distance from I to j for each node. Let's come into the coding part. So over here we are just iterating over up to nth time, and each time we are iterating I to j for each nodes, and simply we are calculating distance of ij via k, that means distance of ik plus distance of kj, and whatever is the minimum we are simply taking that thing. Now let's look into the time complexity. So time complexity over here is basically high. So this will be like, this is run for n times, this is also n times, and this is also n times. So you can say that it will be the n cube, big of n cube time complexity, and space complexity would be the would be the big of n square, because we are simply taking the 2D vectors, and ij and I and j also goes from maybe 0 to n, and also j also goes from 0 to n. So that's why it's big of n square time complexity, space complexity. So but now if it is n square time complexity, and if you are thinking that n equal to 2000, so we cannot apply that n square time complexity. Then how we apply these things? We do not need how we apply these things, like we are computing n equal to 2000, but it is not 2000. We are actually given that we have to deal with only lowercase English letter. so it will be the 26 at max. So over here n equal to 26, and if you compute these things, 26 into 26 into 26, it will give you 1.7 into 10 to the power 4, and this is less than 10 to the power 8, and it can be operated under the 1 second. So this is also acceptable. Now come into the coding part. Now let's write the few algorithms. So first of all, we have to build directed weighted graph. After this building done, so over here n equal to 26, and second step is apply Floyd Warshall algorithm. Now let's come into the coding part. So first of all, let's define long as LL, because we do not need to write each time long, so that we have to less type for it, and define const of LL infinity. This infinity, because we first of all initialize, if we cannot reach in the first iterations, we just initialize as infinity. That's why I take infinity over here. And now let's create the distance array. As I already said, this will be the dist of, it will save dist of I comma j, and this is the 26 as the n equal to 26. This is also 26, so 26 cross 26 array size and initialized by infinity. Now this will for the I equal to j to 26, if distance of I, that means if we in the current this node, so if we from 1 to 1, we cost is 0, because there is no self weighted edge. So this is a simple initializations. This is initialize, and now compute this one. Like we are there is cost, like original, changed, and the cost array, all the size is same, so we take only one size, that will be cost dot size. And first node as original I, we try to convert from u to v, just store this one. So first one is original, taking from original, and second one is taking from changed array. And original I minus ai, this means if the original array have the element b, that is the character b, so we are just simply taking the index number, that means from b minus a, this will give you the 1, because it will just taking the index number, that means a b c d e, for a 0, b 1, c 2, and so on. So this one also same thing, from u and v, both are the numbers, and we just update the distance array as minimum of this one, that will be, first of all this one is infinity, so it will be also updated in the these steps also. So and updated via the cost I, that means how much what is the edge weight. Now this will simply initialize if the initial edges exist. If it is does not exist, so it will be in the infinity, as we already discussed in the initializations part. So now come to the final steps. This is the Floyd Warshall algorithm, and it will run up to 26, like k equal to 0 to 26 iterations, and in each iterations it will go to the I and j, and it will, as I already discussed, it will just update via k node distance I to j. And at last we just process like we are storing these answers. Answer is the sum of minimum cost actually. So we are traveling for the source to source node, and source node and target, like source dot size and target dot size both are equal, so we are taking source dot size, and also over here we are also taking the index number, that will be the s equal to source index current index number, and t for the target, and if it is infinity, that means it does not exist in the distance array, that means we cannot reach there, so it will be written -1 as in the given in the problem. Otherwise we simply add these things. But if you are considering that if it is if the source node have the a and the target node also have a, then what happen? So that in that case, distance of a, that means 0 and 0 would be the 0, as it is already initialized in these steps, like this one, so it will be 0. So we do not need to check whether it is same or equal. It will simply update the dist array accordingly, and we just try to add these things, and finally we return the answer. I think it's clear. Now let's jump into the time complexity part. Okay, so if you look into the time complexity, over here we are just iterating 26 time, so it will be big of 26, and in the next one is this will give you the big of cost dot size, and this one is n cube, that will be the k cube, so it will be go to as 26 to cube. And another one is this one also give you the big O of source dot size. So total time complexity give you big O of 26 and plus, okay, so cost dot size and big O of cost dot size plus big O of 26 to the power 26 cube and big O of source dot size. So you can say what is the cost dot size actually. Let's see the cost dot size constraint. Cost, okay, so cost size is 10 to the power 6. No, this one, not this one. Cost dot size is 2000, and source dot size, this will go as go at 10 to the power 5. So both are in the limit, so it is acceptable, and it is actually accepted by the lit code. Now come into the space complexity of the code. Space complexity. So space complexity, this will take big of 26 square, and another anything else. No, this will be the space complexity, so you can say space complexity give you the big of 26 square. Yeah, thank you guys.